Hello students, welcome back. So students, we in this video we will be solving Cambridge IGCSE. It's 062543 Physics Paper 4 Theory Extended. As you can see, May June 2023. So let's start with our video. Now see, first in figure 1.1 shows a balloon filled with helium gas. Now this balloon is filled with helium gas, and you know helium is a lighter gas, so it rises up. The mass of the balloon is 120 kg. So mass they have given 120 kg. Okay, and calculate the weight of the balloon. Show your working. See, we know that W is weight. W equals M into G. Okay, so we take the value of G as 10. So this is 120 into 10. So that is 1200. So the weight, W is the weight, is 1200 Newton. So the answer is weight is 1200. We write Newton over here. 1200 Newton. Okay. The resultant force on the balloon is 54 Newton. Show that the acceleration of the balloon is 0.45 meter per second square. See, we know that, actually helium is lighter, so it will go up and the weight is going to be down. But that's not our concern, because it's already given that the resultant force on the balloon, and it's obvious that it's a helium balloon, so it is going to rise up. So by so using the formula F equals ma, force is what? Force is 54 Newton, which is equals to m. We know that mass is 120 kg over here. Mass is 120 kg. So 120 into a. So we cross multiply. So this is 54 by 120. That's equal to acceleration. So if you do 54 by 120 in your calculator, you get 0.45 meter per second square, which we have proved. Okay. The balloon accelerates upward from rest. Oh, it's accelerate upward from rest. Okay, so initially this was at rest. Take this as rest. Means initial velocity is 0. We know you should be knowing that U stands for the initial velocity, V stands for the final velocity. So the acceleration is 0.45 meter per second square. Okay, the acceleration is 0.45 meter per second square for 8 seconds. They have given you the time for 8 seconds. Okay, calculate the velocity of the balloon after 8 seconds. So see, to calculate the velocity of the balloon means we have to calculate the final velocity. So final velocity, and you know that by using the formula for the acceleration. What is acceleration? Acceleration is given as A is equals V minus U by T. Okay, so now substituting all the values, this is 0.45 equals V. We have to find V uh, minus U. This is 0 and time is 8 seconds. This is 8 seconds. So 8. So what is the velocity? Velocity will be 0.45 times 8. So this is, if you do it this in your calculator, 0.45 times 8 will give you 3.6. So this is 3.6, hence the final velocity after 8 seconds will be 3.6 meter per second. That's the final velocity. Okay. Calculate the distance traveled by the balloon in the first 8 seconds. Okay, now in the first 8 seconds, see, we know that balloon was initially, it was initially at rest. That means the initial velocity is 0, and with a constant acceleration it is moving, and finally after t equals 8 seconds it achieved a velocity of 3.6. So this is 3.6 meter per second. Now see, distance, we know the distance formula is distance is speed into time. Speed into time. See, we have the time, which is 8 seconds. Now what is the speed? Actually we have to calculate the average speed. And you should know that in case of constant acceleration, see, this balloon is undergoing constant acceleration. So in case of constant acceleration, what is the average speed? Average speed is given by just u plus v. This is v. This will be u plus v by 2. Okay, so u is 0. This is 3.6 by 2, which is 1.8. So the average speed is 1.8 meter per second. So the distance will be speed into time. Speed is 1.8 into time is 8. So if you do 1.8 times 8, that is 14.4. So the distance traveled by the balloon will be 14.4 meter. Yeah. So let's move to the next question. And students, if you are liking the video, so please do like and subscribe. And also, if you find this video be useful to you, so please share with your friends also. They should also get the benefit. So thank you. So let's continue. Now, question 2A part. Now they are saying define pressure. So what is pressure? We know that the pressure is force per unit area. Force per unit area is pressure when given by the formula P equals F, the total force upon the A. The area, sorry, A stands for area. Describe, sorry, the second part. Describe how pressure in a liquid varies with its depth and with its density. Variation with that, variation with density. Now see, let's open the whiteboard. Uh, see, the pressure in liquid is given by pressure in liquids. See, first of all, we should know the formula for the pressure in liquid. Pressure is uh, D into G into H. Okay, so this is what? This is the density. This is the density of liquid. Whatever liquid we are taking, this is the density. We know that G is acceleration due to gravity, which is 10, and here H represents, H represents the depth. So now you can see as H represents the depth. So see, how is the pressure? Pressure is directly proportional to the density of the liquid. That means as the density will increase, the pressure will also increase. Similarly, you can see pressure is also directly proportional to the depth. So as the depth will increase, pressure inside the liquid will also increase. So they are saying describe how pressure in liquid varies with its depth and density. So variation with depth, it increases with depth. So we write it increases with depth, and with density also it increases. So in both cases it will increase as we have seen in the formula. Okay. State two energy sources for which sun is not the main source. Okay, they are saying sun is not the main source. Our hot sun is not the main source. So first is you can write nuclear energy. Though see, the basic thing is that sun is the ultimate source of energy, but it's not the main source. Nuclear energy we obtain from the various like radioactive elements like uranium. And next you can write geothermal energy. That is basically the energy which is inside the core, inside the earth. Geothermal energy. Okay, that's the 2 point. C part. State and explain whether each of the following methods of electrical power generation is renewable. Okay. Power generation in nuclear power station. So, statement power generation in nuclear power station. Nuclear station, I think, is its nuclear power station is non-renewable. I think it's non-renewable. Okay, so nuclear power station is non-renewable. Why? Because first of all, nuclear fuel is used up. Nuclear fuel is used. Okay, so in this nuclear fuel is used, and you know that, like suppose you take uranium, that is not forever, because if we are using uranium, this will be used up and it cannot be replenished. So basically, nuclear fuel is used, and it cannot, you can write, it cannot be used for a very long time, or it cannot be used for like indefinite amount of time, because that had limitation, that ultimately that uranium fuel will be used up. So what you will write, and it cannot be replaced. Yeah, you can write this also. Power generation from the waves in sea. So this statement is this is renewable. Yeah, because first of all, the sea waves, they are not going to end up, because they will keep on, there will be sea waves for a very long time, or you can say for the indefinite time, as long as the earth is there. So this is renewable energy. So uh, explanation is that you can use it. This can be used. No, you write waves will always be produced. Okay, the waves will always be produced in the sea. So they are not going to be used up and will not be used up. Okay, next, third one. State which state of matter, solid, liquid, or gas, has the greatest thermal expansion and which has the least. We know that the greatest expansion is of gases. So it's a gas which has the greatest expansion, and the least expansion is of solids. Though all solid, liquid, and the solid, liquid, and gas expands, but least expansion is of solid and greatest is of gas. Okay. Describe in terms of motion and arrangement of particles the structure of solids and gases. Solids, you can write in solids. You can write solids. You can write particles. Particles are fixed. They cannot move throughout the body liquid. They are fixed and they can only vibrate. They can only vibrate about their mean position. About their mean position. Okay, so they cannot move throughout the body of liquid. Throughout the body as such in case of liquid and gases. So solid, the particles are fixed and they can just vibrate about their mean position. Gases, see, first of all, particles are randomly arranged. So particles are randomly arranged. Randomly arranged. Okay. And they move. They can move freely in all direction. In all direction. They can move freely in all directions. Okay. B. Define specific heat capacity. So this specific heat capacity is the amount of heat energy required to increase the temperature of a unit mass by 1 degree Celsius or 1 Kelvin. So here we write the amount of heat energy. So the amount of heat energy required to increase the temperature of, see, unit mass that could be a gram or in kg, unit mass. Okay, unit mass, so in bracket you can write gram or kg by 1 degree Celsius or 1 Kelvin. See, K represents Kelvin, that by 1 Kelvin. So that is specific heat capacity. B, second part. A student carries out an experiment to determine the specific heat capacity of a metal. Okay, so it is, you have to find the specific capacity. A cylinder of metal is heated by 12 watt. It's heated by a 12 watt electric heater. State the reading that the student takes. See, to measure that specific heat capacity, actually you have to write what readings he is going to take. Okay, let's go to the whiteboard. See, we know that, just remove this. We know that the formula for the specific heat capacity is Q is what? Q is M into C, the specific heat capacity, into delta T. Okay, this is the change in temperature. So for the change in temperature, what he should note? He should note the initial and final temperature. Okay, so for the delta T is what? Initial temperature and final temperature. Okay, just write our first point is initial temperature, and final temperature, initial and final temperature. Okay, now the next point. See, this is you have to measure. Okay, and he should also know the mass. Okay, so let's write here mass. So he should know the mass. And what else point? What else point is that Q. See, Q is the heat energy. Okay, we know that. See, we have given a heater of 12 watt. We know that power is, this is energy by time. Okay, so that's power. So for Q, power is given to us. So what we have to measure? Because what is Q? P into T will give you Q. That is the heat energy over here. So power is given to us. So we have to measure time. So our the third point that he has to measure is time. Okay. So to get the specific heat capacity of metal, he should know the initial temperature and final temperature, mass and time. That's what he should measure. Okay. Now moving on to the fourth question. Okay. In figure 4.1 is an incomplete ray diagram showing an object O. Okay, this is an object O. A converging lens and the principal axis. Okay. The focal point of the lens are each labeled as F. So these are the focal points. Okay, complete the ray diagram to draw the image formed by the lens, label your image. See, as you can see, these rays are diverging. So what we do is that we are going to produce them backward. Okay. So if we produce them backward, we will see they will meet at a point, and that point will be the image. And students, see, I am using the rough hand, but please, it's advisable to use scale. You can just put the scale in a straight line, and you will see that these lines will be intersecting like behind this object. So this will be the image of the object. Okay. Second part, circle 3 description in the list which describes the image form. So first of all, as you can see, this image is what it is, enlarged. Okay, and then this is upright. Yeah, this is upright, is straight image, and it's virtual also. Virtual, why? Because see, they are not, this image is not formed by the actual meeting of the this refracted ray. So when you have to produce it backward so that they meet it over here, so that will be virtual. Okay, say the name of the defect of vision that can be corrected by converging lens. So that actually, the defect is vision is long sightedness. So write long SIG. So long sightedness is the defect of vision. Okay. Describe how converging lens corrects the defect in one. Okay. You may find it helpful to sketch a ray diagram. Okay, see, consider this as your eye. Okay, this is your eye. This is the retina. This part, sorry for this. This part is the retina. Okay, this is the retina where the image has to be formed. Now you know that the front of your eye, this is a converging lens only. Okay, so if you consider this as an object, so that if the rays are coming, so what happens is that the rays cannot converge at retina, so they converges at a point which is away from this. So what you see is a blur image. Okay, this is, just label it retina. Okay, this is your eye lens. Okay, now if suppose we put a converging lens over it, so here this lens is basically will help these rays to converge better. So from here the converging takes place and the image is formed at the retina then, and hence you can see the object. Okay, so this is will be the label diagram. So what you will write, we will write that the converging lens, it's a converging lens, it reduces, what does it reduces? It reduces the focal length. As you can see in the first case, the eye lens has a very large focal length, so that's actually a defect. So that's why we use converging lens. It reduces the focal length and it help to form the image on retina. Okay, so that's our answer. Okay, so moving on to the next question. Fifth, two types of electromagnetic radiations are used in glass optical fibers for high speed broadband. Okay, we know that what are optical fibers. First part, state the type of electromagnetic radiation other than visible light which is used in glass optical fibers. So visible light, and it uses infrared radiations. Okay, Now, second part. Give two reasons why these two types of electromagnetic radiations are used in glass optical fibers for high speed broadband. Okay, first of all, uh, glass is transparent. Glass is transparent. Okay, that's why they are used transparent to visible, visible and infrared rays. Infrared rays. Okay, which we write IR also, infrared rays. Okay, second, see both both visible and infrared rays carry high speed rate of data, so that's why they are used. So what we will write, both visible and infrared rays can carry high speed high speed sorry can carry high, you can say high speed, you don't have to write speed, high data rate, high, or you can write high rate of data. So that's why they are used. Okay, B, second part. The critical angle of a glass in an optical fiber is 45 degree. You know what the critical angle is. Calculate the refractive index of the glass, and we know the formula that refractive index n is equals to 1 upon sine of the critical angle, which is sine 45 degree. So if you write the value, we know that sine 45 degree, just do it in the calculator, you will get 1 by root 2. So basically n will be 1 by root 2. This will be root 2, which is 1.41. So refractive index is 1.41 for that glass. Okay. B. In figure 5.1 shows an optical fiber made up of glass described in one. Okay. Now, on figure 5.1, draw carefully a ray of light in the fiber undergoing total internal reflection. See, first of all, the diagram will be like this. Okay, this. It will go like, you can make like this, go like this, and this. Okay. So see, if you consider this as the normals, okay, these are the normals. You see, this angle is angle of incidence, and you should write that angle of incidence should be greater than the critical angle. So I, this is I, should be greater than 45 degree. So then only the total internal reflection will take place, and then only the optical fiber is going to work. Okay, sixth one. An electrical heater uses a resistance wire of 26 ohm. Okay, the power dissipated in the resistance wire is 2500 watt. Calculate the resistance in the wire. See, we have to calculate the resistance. See what is given. The calculate the current in the resistance wire. See, we have been given the resistance R, that is 26 ohm. Okay, and we have been given the power, which is 2500 watts. Okay, what do we have to find? The current I. Now, first of all, now we should know. See, let's go to the whiteboard. Because okay, so see, first of all, you should know the formula. We know that power is V into I. Okay, that's the formula. And by the Ohm's law, we know that what is V? V is IR. Okay, now substituting the value of V over here, power is, this is IR. So IR into I, this power will be I square R. Now we can use the formula in the this thing. So, okay, so the formula is P equals to I square R. Okay, we the P and the R and P is given to us, we can find I. So cross multiply, P by R will be equal to I square. So how you will give I? I is under root of P by R, that is under root of 2500 by 26. Now you put this in your calculator. 2526 will give you 9.8 ampere, rounding it off to 1 decimal place. Okay, now the resistance is B part. The resistance of wire of the heater has a length of 1.2 meter. Okay, let's write it over here. Length is 1.2 meter, and the cross sectional area is 7.9 into 10 to the power minus 7 meter square. Done. Okay. Now, the new heater is designed using wire of same material. Okay, the material is same material with a length of 1.8 meter. So this is 1.8 meter and cross-sectional area as 5.8 into 10 to the power minus 7 meter square. Okay, calculate the resistance of this wire. Okay, means you have to calculate the resistance of this wire. So first of all, we should know the relation, see, between the length and the area of cross section. We know that the length is directly proportional to, sorry, the resistance is directly proportional to the length and inversely proportional to the area of cross section. That means as the wire becomes longer, the resistance increase. As the wire becomes thicker, the resistance will decrease. Now you see that what is the length? 1.2 into 1. First of all, sorry for that. The resistance is already 26 ohm that is given to us. Okay. So we write 26 ohm over here. So for the new wire, see 1.8 upon 1.2. You do the ratio. 1.8 upon 1.2. Sorry for this. This is 1.2. 1.2. This is how much? This is 1.5. Okay. So it's directly proportional. So what do you do? Into 1.5. Okay. Now this wire, see, this wire is thicker. This is thinner. That means again the area of cross section is decreasing. And we know that resistance is inversely proportional to area of cross section. That means if the area is decreasing, the resistance will increase. Now the thing is that how much it is decreasing. So we again find the ratio 7.9 into 10 to the power minus 7 upon 5.8 into 10 to the power minus 7. This and this will get cancelled. Use your calculator. 7.9 upon 5.8. That will give you around 1.36. 1.36. So again I am repeating, this is getting thinner, so the resistance will increase into 1.36. So the new resistance of the wire will be 26 into 1.5 into 1.36. If you put this in your calculator, it's coming out to be 53.04 something. So you can round it off to 53 ohm. So the resistance of new wire is 53 ohm. Okay. C part. 2500 watt heater is used in a country where electrical cost is $0.30. See this, per kilowatt hour. Okay. Calculate the cost of using the heater continuously for 2 days. See, what is the cost? The unit is, so unit of electricity is how much? $0.30 per kilowatt hour. So you have to convert this to, first of all, kilowatt. So 2500 by 1000 is 2.5 kilowatt. Okay, kilowatt. Now what do you have to do? How much time? 2 days. So how many hours in 2 days? So 2 in 1 day it is 24 hours. So which is 48 hours. Okay. So how much kilowatt hour they have used? 2.5 into 48. So that is 120 kilowatt hour they have used. They means the heater has used. And what's the unit? For 1 kilowatt hour it is 0.30. So for 120 kilowatt hour, 120 into 0.30, that is 36. The cost will be $36. Okay. Question 7th. The voltage across a primary coil of a 100% efficient transformer, see, this is VP they have given, is 220 volts. And the voltage across the secondary coil is VS is 12 volt. Okay. The current in the secondary coil IS is 2.5 ampere they have given. Okay. Calculate the current in the primary coil IP. You have to calculate the IP. See, we have learned the formula in the transformer, that is VP into IP equals VS into IS. Now, using this formula and substituting the values, so VP is 220. You have to find IP. Okay, we have to find the current in the primary coil. So just write this IP, which is equal to VS. Voltage in the secondary coil is 12 volt. 12 volt, and voltage in, sorry, current in secondary coil is 2.5. So 12. So IP will be, so this current in the primary coil will be 12 times 2.5 divided by 220. So this IP, if you substitute this in calculator, this will be 0, is coming to be 0.136 ampere. So you can round it off and you can write 0.14 ampere. Okay. Now, B part. Calculate the ratio of the number of turns on the primary coil to the number of turns on the secondary coil of the transformer. Okay, see, first of all, you should know this ratio, that is Vp by Vs, primary by secondary, equals Np, number of turns in primary coil upon number of turns in secondary coil. So this is the ratio. We know that. What was the voltage in the primary coil? See, this was 220, as you can see, 220, and Vs is 12. So this is substituting the values 220 by 12. Okay, so the ratio of Np by Ns, we can write Np by Ns ratio as 220 is to 12, and if you solve it in the calculator, this is approximately 18 is to 1 ratio. So that's the answer. Okay, now coming on to the 8th question. During beta decay, one of the neutron in the nucleus changes. State what happens to this neutron. See, you should know that during a beta decay, see, let's go to the whiteboard. During a beta decay, see, in case of a beta decay, you know, that neutron is converted into a proton and an electron. So this neutron and 10 will give you, first I'm writing electron first. Electron is actually this beta particle only, B0 minus 1, because the mass of electron is 0 and the charge is minus 1. This beta particle is basically electron and one proton, which has one mass and one charge. Okay, so now state what happens to this neutron. So neutron is converted to a beta particle 0 minus 1 and a proton P11. Okay, now second part, explain how charge is conserved during this reaction. Up, see, neutron, see, if you see that the mass number, so neutron has mass 1, and you see that the mass of total on this right hand side, beta and proton, is 0 plus 1, that is 1 only. Okay, so because beta has 0 mass and proton has 1, so that's equal. Similarly, neutron, what is the charge on neutron? The charge on neutron is 0 and you can see beta plus proton, if you do, this is minus 1 plus 1, that equals 0, because this is beta, this is for beta and this is for proton, hence the total charge is conserved during this reaction. Okay, that's the nuclear reaction. Now, B part, coming on to the B part, complete the nuclide equation of the alpha decay of the radon 212 to form an isotope of polonium symbol PO. Now see, this is radon, which is 212.26. We know that what is an alpha decay? Alpha decay, that's right, alpha decay is, you see, alpha you can write as helium nuclei He42, or just alpha, which has 4 unit mass and 2 charge. So I'm writing just alpha, which has 4 unit mass and 2 charge. Now polonium will symbol is PO. Now what will be the mass? 212. So this is already 4 over there. So 212 minus 4, 208. So mass is 208. Similarly, this is 86. This is 2 already over there. So we write 84. Because you have to balance the total mass and the total charge. Okay. As you can see, 212 equals 208 plus 4. And this is 86 is equals 84 plus 2. That's the answer. Okay. Ninth one. Yeah, has a ninth one. In figure 9.1 shows the sun as a central dot. Okay. This is the sun. Planets Saturn, Jupiter, Earth labeled as S0 is for Saturn. This is Jupiter, this is Earth. Okay. The planets orbit the sun anticlockwise. You can see this direction is anticlockwise. From Earth's orbit, the planets appear aligned. So this is called aligned. Okay. Now assume that the sun takes the Saturn takes 30 years to orbit the sun. Means one complete orbit, it is taking 30 years, and the Jupiter takes 12 years to orbit the sun. Okay. On figure 9.1, mark the position of Saturn and Jupiter 5 years after their original positions shown. So this is their original position. Okay. So let's talk about Saturn first. Okay. Saturn takes 30 years. So see, in 30 years, so let's talk about Saturn. I'm writing Saturn. Saturn takes 30, so this is N. Saturn takes 30 years to complete 360 degree. Simple. Unitary method. So 1 year it will take 360. It will rotate 360 by 30 degree. Okay. So in 5 years, because we have to calculate for 5 years. So in 5 years, the Saturn will rotate 360 by 30 into 5. If you solve it, this goes 1, this goes 6 times, 5 6 are 30, and this is 6 6 are 36, so 60 degree. So see, but I'm right, I'm doing it with a rough hand, but you please use a protector. So you make, with the protector, you make an angle of 60 degree. Okay, so this will be the position of Saturn. So this is what, this is 60 degree for the Saturn. Now for the Jupiter. Now I'm writing for Jupiter. Okay, because in anti-clockwise, so you take this angle. Okay. Jupiter is, see, it takes 12 years. Okay, so 12 years to orbit the sun. So uh, sorry, Jupiter, it takes 12 years to orbit the sun 360 degree. Okay, so in 1 year, how much is 360 by 12? So let's solve it. 12 goes 3 times na? So in 1 year, 30 degree. So in 5 year, this will go 5 into 30, which is 150 degree. Okay, now see, 150 degree is almost like, use the protector please. 150 degree will be almost like over here. So this will be the position of Jupiter after 5 year, and this angle is 150 degree. Okay. So this is for the A part. Show your working. Okay. Now on figure 9.1 only. Okay. Mark the position of Saturn and Jupiter 20 years after the original position shown in mark 9.1. So see, original position to was this only. So from here, now what we have to calculate for 20 years. So again, for taking Saturn, S2 stands for Saturn. The position of S2 will be, okay. See, have I written S1? No. See, I have made a mistake. This is S1. This is the initial position. Take this as S1, and this is for J1, Jupiter. Now S2 and J2. Okay. So S2 again. See, Saturn is taking uh, taking 30 years to complete 360 degree. Okay, 30 years to complete 360 degree. So in 1 year, how much? 360 by 30. Solve this. This goes 12 degree. And in 20 years, it will do 12 into 20. That means 240 degree. Okay. So S2 position is 240 degree. That means this from this original position. Okay. So this is 180. This will be 270. So 240 will be around here. I'm considering this S2. So this angle, this from this mark it with the red pen now. So this is 240 degree. Okay. Now again taking for the Jupiter. Now for J2. See, J2 is Jupiter is covering, taking 12 years to do the complete rotation, which is 360 degree. 12 years. So again, unitary method. 1 year, this will take 360 by 12, which is 30 degree. And in 20 years, it will do 30 into 20, which is 600 degree. Okay, now 600 degree is what? See, for the Jupiter, so I'm doing this in a green. Okay, for the Jupiter, it has completed that one rotation 360 degree. So what you will do, 600 minus 360 is how much? This is 240. Now see this. See, in one complete rotation, it has completed 360 degree, and again from here only, it will go 240 degree. So this will be the J2. So this angle is also 240 degree. This is the position of J2. Means that they are again aligned in 20 years. Okay. State what is observed from Earth's orbit after 20 years. So you can write Saturn and Jupiter are again aligned now. Okay, they are aligned. Okay, choose two words from the list to describe each planet. Okay, Jupiter. We know that Jupiter is a gaseous planet, and it is very large as compared to Earth. Okay, large. Earth is a rocky planet, and Earth is small as compared to Jupiter. Okay, the average density of Jupiter is much less than that of Earth. Yeah, the gravitational field strength at the surface of Jupiter is greater than that at the surface of Earth. Okay, explain how these differences in density and in gravitational field strength are consistent with your answer to C first. See, density. Density is why? Because Jupiter has a lower density. Jupiter has lower density. Lower density, why? Because it is made up of gases only. Okay, whereas Earth is rocky. So that's obvious. Jupiter is going to have lower density. The gravitational field strength depends on the mass. So it has the mass. So Jupiter, we know that Jupiter is very large. Jupiter is larger than Earth, or you can say has more mass, and we know that more mass than Earth. When we know that the gravitational field strength depends upon the mass only. Okay, D part. The average density of the Jupiter is 1300 kilogram per meter cube, and the volume is 1.4 into 10 to the power 15 kilometer cube. Okay, calculate the mass of Jupiter. See, they have given this in kilometer cube. So this is the tricky part. What's the density? Density is 1300 kilogram per meter cube. Okay, so we have to convert this, and the volume is 1.4 into 10 to the power 15. See, 1 kilometer is how much? 1000 meter. 1000 meter, and then cube it. So basically this will be 1.4 into 10 to the power 15. 1000 is actually 10 to the power 3. 1000 is 10 to the power 3 and then whole 3. So this is 10 to the power 9. So this is into 10 to the power 9. So which is 1.4 into 10 to the power. Now what is 15 plus 9? Uh, if you see, just a second. I think my system is hanging. So yeah, 15 plus 9 is 24. Okay, so now what is mass? You know the formula, mass is volume into density. Okay, so that is volume is 1.4 into 10 to the power 24 into 1300. So you just substitute this value in calculator, and this will be 1.82 into 10 to the power 27 kg, which will be our mass. So mass is 1.82 into 10 to the power 27 kg. So that's the mass. Okay, now the last question, 10th one. Show that 1 light year is 9.5 into 10 to the power 15 meter. See, 1 light year is the distance traveled by the light in 1 year. So, so what do we have to do? See, first of all, what is the speed of light? We take the speed of light. The speed of light is 3 into 10 to the power 8 meter per second. Okay. Now, in a year, so what do we have to calculate? We have to calculate number of seconds in 1 year. So we are calculating the number of seconds in 1 year. Okay, so that will be, we know that in 1 year there are 365 days. In 1 day there is 24 hours. In 1 hour there is 60 minutes. And in 1 minute there is 60 seconds. So if you do this in the calculator, 365 into 24 into 60 into 60, you get 3153600 seconds. So what is the distance? Distance is, this is the speed and this much is the time. So speed into time, 3 into 10 to the power 8 into 3153600, you will be getting approximately exact this answer, not exact, like approximately 9.5 when you round it off into 10 to the power 15 meter. So this is the working. Okay. B, first part. State one measurement that is taken when determining the speed v at which a galaxy is moving away from Earth. So see, when it comes with for the galaxies, that's a red shift. Actually, we measure that in a red shift. Okay, because that is, we know that the galaxies which are going far away, means which are going far from Earth, they'll show the red shift, and which are coming closer towards our galaxy, that will show the blue shift. So that is the change in wavelength. Change in wavelength of galaxy starlight. Okay. Write down the equation relating v and the distance d for a far galaxy. So that is given by the Hubble's constant. Hubble's constant, you know, Hubble constant HO, which is equals to v, relating the v, the speed, and the d. Okay, the distance d of a galaxy, that is Hubble's constant. Okay, state how the distance d of a far galaxy can be determined other than using the equation in 2. So see, we can use the brightness. See, brightness of supernova. So you can calculate the measurement by using the brightness of supernova, and you can find the distance of galaxy. So students, that's all for today video, and soon I'll be coming with more such videos. So thanks for watching. Keep on sharing, liking, and subscribing. So see you on the next video. Thank you.